this video, I will solve last exercise, last main questions from your trigonometry chapter. I know most of the students from class 10th are a bit confused with these questions. So I will try to simplify the solutions here. So let me start with the first question. So here in the LHS we have cosecant theta minus cot theta whole square, and we need to prove this LHS is equal to 1 minus cos theta in the numerator and then 1 plus cos theta in the denominator. So let me take the LHS. So we have cosecant theta minus cot theta whole square. So I will use this identity a minus b whole square, which is equal to a square plus b square minus 2ab, right? So here this is your a and this one is your b. So you will get cosecant square theta plus cot square theta minus 2 times cosecant theta into cot theta. So here this cosecant square theta can be written as 1 by sine square theta. You know this cosecant is a reciprocal of sine. Next, cot square can be written as cos square theta divided by sine square theta. Okay, so minus 2 cosecant, again reciprocal of sine, cot cos theta by sine theta, right? So now here if you simplify this, you will get sine square theta in the denominator. Let me write it here, 1 plus 1 by sine square theta plus cos square theta by sine square theta minus 2 cos theta in the denominator, product of these two, that is sine square theta. Okay, so now these are three fractions, 1, 2 and then 3. So just apply fraction addition here. So as we have the same denominator, I will take sine square theta in the denominator and then 1 plus cos square theta minus 2 cos theta in the numerator. Okay, fine. So now see here, whenever you solve these two proof questions, you need to keep this expression in mind. So what we need 1 minus cos theta by 1 plus cos theta at the end of this solution, right? 1 minus cos theta by 1 plus cos theta. So now how to get this 1 plus cos theta in the denominator? You won't get this 1 plus cos theta from sine square theta, right? So now we need to make some changes to this sine square theta. So how can you make some changes here to get this 1 plus cos square theta, 1 plus cos theta? See here, we know the first identity. What is the first identity? Sine square theta plus cos square theta is equal to 1. Then this sine square theta can be written as 1 minus cos square theta. Okay, fine. So then how you will get this 1 plus cos square theta, 1 plus cos theta? Again you need to use one more identity. See here, this 1 minus cos square theta can be written as 1 square minus cos square theta. Yes or no? Now algebraic identity a square minus b square, and we know a square minus b square can be written as a plus b into a minus b. So here this 1 is a and then cos theta is b. Then if you apply this algebraic identity here, you will get 1 plus cos theta into 1 minus cos theta. Okay, so now we got 1 plus cos theta. Okay, so then I will replace the denominator sine square theta by, I will replace this sine square theta by 1 plus cos theta into 1 minus cos theta. Fine then. So what we need in the numerator? We need 1 minus cos theta. Now how to get 1 minus cos theta out of this? How to get 1 minus cos theta out of this numerator, right? So now again see here, throughout this problem we are using three identities. This is our first identity, this is our second identity, algebraic identities, and then here We know that this 1 can be written as 1 square, and then we have cos square theta here minus 2 cos theta. So can I write this expression as 1 square plus cos square theta minus 2 into, this is your a 1, and this can be taken as b cos theta. Now compare these two. These two expanded forms are similar. So can I take this as a, this as b? Then I will get a minus b whole square. That is our 1 minus cos theta whole square. Okay. Now see here, 1 minus cos theta whole square and then 1 minus cos theta. Now you can cancel out this 1 minus cos theta from the denominator. What is 1 minus cos theta whole square? There are two 1 minus cos thetas. So I will remove 1. Okay. Fine. So you will be left with 1 minus cos theta in the numerator and then 1 plus cos theta in the denominator. So this is the required RHS. Okay. So I hope I made clear too. So in the LHS we have cos A divided by 1 plus sin A plus 1 plus sin A divided by cos A. Now we need to prove this expression is equal to 2 secant A. So first thing, you need to consider these two terms as some fractions and then operate them just as fractions. So now here we know how to find the LCM of these two. Okay, so just find the product of these two, that will be your LCM here. So now the LCM of 1 plus sin A and then cos A is 1 plus sin A into cos A. Okay, so here now cross multiply cos A and then 1 plus sin A. We are not using any trigonometric identity here, we are just operating these as some fractions, right? So then cos A into cos A is cos square A, and then here 1 plus sin A the whole square. Fine. Keep the denominator as it is, 1 plus sin A and then cos A. So here cos square A, again just keep it as it is. We have 1 plus sin A whole square, and we know the identity, that is A plus B whole square, which is equal to A square plus B square plus 2AB. So here 1 is A and then sin A is B, right? So then you will get A square. What is A square here? 1. So you will get 1 square plus B square, that is sin square, plus 2 into 1 into sin A, or you can just write it as 2 into sin A. Next step. So now here, see here. So whenever you solve these two proof questions, you need to keep in mind this. After solving this, okay, at the end we need this 2 secant A, right? We need the 2 secant A as a final answer. So now just take this expression. How you will get this 2 secant A? 2 secant A is what? This can be written as 2 divided by cos A, because 1 by cos A is secant A. So now we need this cos A in the denominator, and we already have this cos A here. So now our job is to just remove the remaining expressions or remaining terms from this. So now how to remove this remaining part? So now we need to use some trigonometric identities and then simplify. See here, in this expression we have cos square and then sin square, and we know that sin square A plus cos square A is equal to 1, the first trigonometric identity. Then this will simplify to cos square plus sin square A is 1, and then 1 square is 1 plus 2 sin A. Now keep the denominator as it is, 1 plus sin A and then cos A. Okay, so now here we got 1 plus 1, 2, and then 2 sin A whole divided by 1 plus sin A into cos A. Now take 2 common from these two terms, then you will get 1 plus sin A divided by 1 plus sin A into cos A. Okay, so now here we got the same terms in the numerator and denominator. Now you can just cancel out these two, right? So now you are left with 2 in the numerator and then cos A in the denominator, which is equal to 2 into 1 by cos A, that is secant A. Okay, so what are the steps are important here? First, operating these two, okay, operating the LHS as just some fractions, and then using the first trigonometric identity, taking common, and then cancel out these two terms. Okay, number 3. So here in the LHS we have this tan and cot, and in the RHS we have this secant theta and then cosecant theta. So here your first step must be taking this tan and cot as ratio of sin and cos. Even this is given as hint in your textbook. So let me start from taking these as ratios of sin and cos. Okay, so your LHS is sin theta by cos theta, and then 1 minus cot theta, that is 1 minus cos theta by sin theta, okay, plus cos theta by sin theta, and in the denominator 1 minus sin theta by cos theta. So here you are comfortable with the ratios, right? So it is bit lengthy but not that complicated. Just go with the flow, right? So take these as some fractions and then simplify. So now if I take these as a fractions, so what I will get in the denominator, so this is your first term, I will get 1 minus cos theta by sin theta. So here you have 1, then what is the LCM? You will get sin theta, okay, and here cross multiply, you will get sin theta minus cos theta, okay, 1 by 1 minus cos theta by sin theta. Sin theta LCM, if you just cross multiply 1 into sin theta, and here sin theta into 1, that will give cos theta here, right? So this is the denominator, and in the numerator you will get, keep it as it is, sin theta by cos theta, okay. Again here denominator, the LCM is cos theta, if you cross multiply you will get cos theta minus sin theta, and in the numerator cos theta by sin theta, okay. So next step, I will take this sin theta by cos theta here and then multiplied by, okay, so we need to take a reciprocal of this, yes or no, because this is a division. If I take, let me keep it as division, okay, so divided by sin theta minus cos theta and then sin theta, okay, and the second term, what is the second term here? Cos theta divided by sin theta whole divided by cos theta minus sin theta and then cos theta here, right? Okay, so let me solve the first term, sin theta cos theta. So this division will change to multiplication, and then we need to take a reciprocal of this. You know this, right, while operating fractions. So now I will take sin theta in the numerator and then sin theta minus cos theta in the denominator. So say cos theta divided by sin theta into reciprocal cos theta divided by cos theta minus sin theta. So till here we have not used any identities either from algebra or trigonometry. We are just solving some fractions here, okay, fine. So next, after this step, sin theta by cos theta, so just multiply. What is sin theta into sin theta? You will get sin square theta divided by cos theta into sin theta minus cos theta, keep as it is, cos theta into sin theta minus cos theta. Okay, so this is our first term, and in the second term you have plus, okay, cos theta into cos theta, these two, cos theta into cos theta, cos square theta, and then in the denominator again the product sin theta into cos theta minus sin theta. Okay, fine. So now again you need to consider these two as two fractions and then simplify. So now if I take these two as fractions, then what would be the LCM? This step is important. Most of you guys are a bit confused with taking LCM and you have these algebraic expressions or trigonometric expressions. So I will give you an example. See here, if you have 1 by x into a plus b, okay, let me take a plus b, plus 1 by y into a plus b, right? So then what is the LCM here? So here your LCM will be x into y a plus b, because here what is LCM? It must be a multiple of these two terms. So if I multiply y with this term, I will get this expression, and if I multiply x with this term, I will get the same expression, right? So now just compare these two. This is your x, a plus b, this is your y, a plus b. Then what would be the LCM here? Then your LCM will be product of cos and sin, that is x and y, cos theta into sin theta. All right, and we have a plus b and a plus b here, but here we have sin theta minus cos theta minus sin theta. So we need to make these two as same expressions. So how can you make these two as same expressions? Just switch these two terms. How can you switch these two terms? Multiply it with a negative sign. So if I multiply minus in the numerator and minus in the denominator, then take this minus terms to these two terms. So what you will get? Minus cos theta plus sin theta, yes or no? If I multiply minus sin with these two terms, you will get minus cos theta and then plus sin theta. And now we can switch these two terms. So let me just change it here itself. So I will take it as we multiplied this minus sign with these two terms, then we got minus cos theta plus sin theta, or you can write it as sin theta minus cos theta. Okay, now we got the same terms, and I will take this minus sign here. Okay, fine. So now we got the same terms, then LCM is sin theta minus cos theta. Okay, fine. So now if you multiply sin theta with this expression, you will get the LCM. So then I will take that sin theta in the numerator, and if you multiply cos theta with this expression, you will get the LCM. I will take cos theta in the numerator. Okay, so let me just remove this part. Fine. Now add these two. What you will get? You will get sin cube theta, sin square into sin cube theta minus cos cube theta. All right. Okay. So now again, what we need? We need 1 plus secant theta cosecant theta at the end of the solution, right? So now how to get this 1 plus secant theta cosecant theta out of this? So that is the question here. So now see here, if you want, you can just simplify this. How you will get secant theta and cos theta? What are these secant theta and cos theta? They are reciprocals of cos theta and sin theta, yes or no? So then this is what? 1 plus 1 divided by secant theta is 1 by cos theta, and what is cosecant theta? 1 by sin theta. Then we need this cos theta and sin theta in the denominator, and we already got these two. Then you need to just get rid of these expressions. Just get rid of the remaining expression. Then you will get this at the end of the solution. Now we need to use some trigonometric identities and then algebraic identities. So see here, in the numerator you have this a cube minus b cube. So then which algebraic identity we will use? We know that a cube minus b cube can be written as a minus b into a square plus b square plus ab. Okay, you need to remember this one. This a cube minus b cube can be written as a square plus b square plus ab, right? So then this numerator will become, so what is a here? Sine is a and then cos is b. Then our numerator is a minus b, that is sine theta minus cos theta, and then a square plus b square plus ab, sine square theta plus cos square theta plus ab, that is sine theta into cos theta, sine theta into cos theta, right? So this is the numerator, and in the denominator you have keep it as it is, cos theta into sine theta and then sine minus cos. Okay, see here, now you need to use the trigonometric identity. What is sine square plus cos square? That is 1. Sine square plus cos square can be written as 1. So then I will replace the sine square plus cos square with 1. Keep this, see here, sine theta minus cos theta, sine theta minus cos theta. So these two expressions are same, just cancel out these two. So if I cancel out these two, then I will be left with sine square plus cos square is 1 plus sine theta into cos, and in the denominator just cos theta sine theta. So 95% of the solution is completed till this step. Okay, so this particular step is important, getting this from this step. So and this identity, just concentrate on these two steps, right? Okay, so after this, see here, 1 plus sine theta cos theta, you know this one, right? 1 plus x divided by xy, what we will get? This is a common denominator for these two terms, then this can be written as 1 by xy plus x by xy. So similarly, this is a common denominator for these two terms, then it can be written as 1 by cos theta into sin theta plus sin cos divided by cos into sin. So a into b or b into a both are same, then I will just cancel out these two, then you are left with 1 by cos theta. What is 1 by cos theta? Secant theta. 1 by sin theta cosecant theta plus 1, or you can write it as 1 plus secant theta cosecant theta. So which is the required RHS, right? Yes or no? 1 plus just, okay, so we will get it in a single sheet, right? So this was the required answer which we got here, right? So just concentrating on this part is important, right? This identity here, and then cancelling out these two terms, and then taking this as 1. All right, okay, even this step is also important, taking the negative term and making these two terms as same. Okay.